Hello everyone, welcome to a new tutorial presented by the SHRDB. In this tutorial, we are going to learn how to plot parametric functions and polar functions. Now, parametric function, let's start with mathematics, a brief introduction to mathematics. Parametric functions are functions which have a variable which is not x and y. So let's say we normally have functions. We normally have functions which are relating x and y. So we have y is equals to x plus 1. So y is equals to x plus 1 is a function which relates x and y. But there exist other functions which does not relate x directly to y, and they are parametric functions. So let's say you have y is equals to t plus 1. So y is equals to t plus, let's say y is equals to t plus 1, and we have again another function beside. We have x is equals to t plus 20 or t plus 4. So we have the function. We see that here a parametric function consists of a variable t, which is going to be a variable of the x variable, and is also going to be a variable of the y variable. Now you are capable of changing it. If you now place t as being a factor, and then you say t will be here, t is equals to, in this case, x minus 4. You can place this x minus 4 now in this equation. When you are going to place x minus 4 in this equation, relating the two equations, you are going to have the function t, or you have the going to function have y is equals to, if I place now this x here equals to t, this t is equals to x minus 4 back into this, I'm going to have x minus 4 plus 1. So it's going to form x minus 3. So it's x minus 4 plus 1, which is going to be equal to x minus 3. So this is what you are going to have. So your y now is going to be x minus 3. So plotting this curve, x equals to t plus 4 and y equals to t plus 1, is similar to plotting this curve y is equals to x minus 3. So this is parametric function. So now let's start by plotting in our normal mode the function y is equals to x minus 3. So we initially started by setting the value of x. We have already set the value of x, we have set the range of y, set the range of x, and we have placed the domain. We have already placed the arrow for us to have all this diagram. So everything was placed in order to have this diagram. Now we are going to go up now and then plot the line x. We are going to plot the line y is equals to x minus 3. So we just write x minus 3 here. So this is the line y is equals to x minus 3. So I'm going to place the key outside, set key outside, so that it does not disturb my curve. So when I set the key outside, I then come here, my key is outside, and this is my curve. Now if I want to plot now this parametric function, so I want to plot in terms of t. Now you see that if I want to plot in terms of t, I can come here on this part here, on this general, you use parametric and then you set parametric. So this is a simple method. You say it's going to set parametric. Now what you have to put in your mind is that dummy variable in this time when we are setting parametric is t. The dummy variable is the variable that GNU plot considers to be plotted, to be plotted. We've seen that when you plotted, if you plot, let's say x squared. No, we have already set the parametric. So now you see that let's first try to unset parametric first. So now you see the dummy variable is x for curves. Now you see that here the GNU plot consider x as being a variable, the main variable for plotting functions, our function f of x. Now let's say you want to plot a function when you are out of the parametric as, let's say, I want to plot the function sine z. So I'll come plot within that domain sine, instead here z. So I'll plot sine z. So when I plot sine z, you see it undefined variable. But if I plot, in this case, I instead plot sine x, you realize that a plotting scheme is formed. You have a diagram which is formed to you. But when you decide to plot sine z, it is refusing. It's because the GNU plot does not consider z as being the variable for plotting. The variable for plotting is called a dummy variable, and that variable is x when we are plotting curves in GNU plot. So for plots, this is plot for plots which are relating y is equals to f of x. You are going to use your dummy variable, the variable that GNU plot is going to consider as being x. Now let's say I still want to plot here sine t. So this is normal. You say that this is undefined when you want to plot the curve y is equals to x. Now to plot now parametric function, I'm going to set parametric. So when I set parametric as well, you see now the new dummy variable is t. So you cannot plot a curve in this case as being as using x in this time around. So now to plot these curves, you see that, let's say I want to plot t plus 1. Let's start by having an error. So you see that when you plot now in this case t plus 1, you realize that parametric function is not fully defined. So when you know that parametric function exists in two instances, you are going to have an instance which is going to correspond to y, another instance is going to correspond to x. The first instance is going to correspond to x, and the next instance is going to correspond to y. So for us to plot this same curve we initially had, which is y is equals to x minus 3, we need to place this t plus 4 comma, and then we place this t plus 1 here. So let's see how to plot. So we are going to plot within that range, and we are going to say t plus 4 first for the x correspondence, t plus 4, and then we place a comma, and then we place t plus 1 for the y correspondence. So when you have this, you have the exact graph that we initially had for y is equals to x minus 3. So let's draw again the graph of y is equals to x minus 3. We set dummy, we unset parametric. So unset parametric. So now the dummy variable is going to be x. Now we are going to plot instead the curve y is equals to x minus 3. So when we do that, we see that this graph is similar to what we had initially. So the other one was in case when it was parametric, and now in this case is when it is normal mode. So you can still set again parametric and see how to plot different types of functions. So now we are going to plot within that same range. Now is sine x sine t cos t. So let's sine this sine, let's say we place here t, and we place comma, we place cos t, cos in bracket t. So the first case here is when x is equals to sine t, and the next case is when y is equals to sine k. All of this is going to produce this graph here, a circle, sine t cos t. So let's say we want again to plot another graph with tan t comma and sine t. We are now going to have this graph here. So when you want to plot this tan t and sine t, you are going to have this graph. So these are different ways to plot the graph in your parametric functions. So we can decide again to plot again with a, let's say I want to plot now instead a t squared plus 5 comma, When I place t squared plus 5 and then I'm going to plot again another part, my another part is going to be, let's say, t plus 1. So all of this is going to produce now this curve. If I want to change a little bit, I can place here sine t. So you are going to have this graph. So these are the graphs that involve mainly with your parametric functions. Now let's see the next part, which is going to be plotting polar functions, because this tutorial is involved with these two parts. So now in this, the other part will be for polar functions. So now you have polar functions. Now let's plot polar function. In order for you to plot polar function, the first thing to put in your mind is that you need to come to general and then you have to set polar. So you have to come here and say polar. You set polar. When you set polar, the next thing to put in your mind is what are you going to plot now in cases of polar function. In polar function, the domain is no more in degrees. So when you set polar, the next thing to put in your mind, the domain is no more with length of x as such here. Now in polar equation, the x is corresponding to angles, and need to have a brief introduction to polar equation before we move on to it. In polar equation, you know that in normal equations, we have x and y as being the points of your graph. You have normally x and y being the points of your graph. In their normal function, y is equal to f of x. Now, in functions which are polar functions, you need to know that in this case, it is the points are going to be instead theta, the angle theta, and the r. So r is going to be the radius from the center, while theta is going to be the angle. So now the range here, we need to change this range from negative 2 pi to pi. Or if you want to use angle, we need to set angle degrees. So in order for me to use angle, I'm going to set angle in degrees first. In order to use the angles in degrees, so set angle degree. When I've set angle degree, now I can now come and I plot here. So I'll use now this plot. Now the domain I'm going to place here in this plot is not going to be from negative 10 to negative to 10 now, but it's going to be from negative 360 degrees, from negative 360 degrees to 360 degrees. So this is a new domain here, to 360 degrees. When you have this new domain, you then come here down. You continue by saying now the function, the polar function are going to be in cases of the polar. When you want to represent polar function in this point here, normally it was if in the normal mode you have function the y is equal to f of x, which is placed here. But in polar function, you instead have the function r is equal to f of theta, which is placed here. So let's say I want to draw sine theta. Sine theta, I'll correspond it to x. So you see that when you place polar, set polar, the domain still remain x. It does not tell you that the domain is t, nor domain is x. So here the domain is still x. So I'll remove this comma and I place a colon. The problem shows because we didn't unset the polar, the parametric equation. So when you want to do this, you need to unset first the parametric. So when you come down, you unset parametric. After unsetting the parametric, now you set polar. After setting polar, you ask now the dummy to the machine for it to tell you which the variable that considers as theta in your function, your GNU plot platform. So I'll ask it to show me the dummy. The dummy variable is considered as t when you unset the parametric. So now I'll come back again and I'll plot here with sine t. So now you see that when you plot this type of curve, it's very small, because the range of x and y are too large. So you need to increase the range of, and you need to decrease the range of x and y So this is the plot you have. So when I come here, I set the x range. I'm going to change the x range and place it at let's say I place a very small value, -2 and -2, -2 to 2. So this is my x range, and I'll do similar with the y range. So I have y here. So now I'll come here again on my plot and see what happened. So you see that when I change the x and y range, you have a larger view of what you see, that my sine t is going to be plotted as being a circle when you have polar equations, polar plotting, polar functions. Now let's say I still want to plot again another function, but with the polar function a sine t. So inside here, my a, let's say I will say 5, so it will be 5 times sine t. So this is going to be my new plot. You see that now it has been enlarged. In order for you to see now these other parts which are found here, I need to increase the curve. So for me to do that, I'll increase again the set y range. I'll increase to -20, and that of this I'll increase to 20. I'll do it similar with the y range. So when I do this, I come back again to my curve. You have this. So you see that can be seen now very well with this one when I increase my range. So now you see it's still a circle. Now I'll plot now instead using the different. I'll set again with. So now let's say I'll plot now instead cos in this time around, cos t. So when I plot cos t, you see it's shifted in front here, but it's very small. In order for me to see very well, I need to set it back up with -2 and then come down here and I set it with y. So when I do this, you see that it has shifted from the sine t and now it's at this position here. So this is how we visualize it. So now lastly, the last one we are going to visualize today is going to be the cos t squared plus 5. So you see how it's going to show. So this is not shown very clearly because of the routing. So you need to a programming style needs to be done again very well. So because of the smoothing. So let's say I'm going to have cos t plus 5 instead here, cos t squared only. So let's say I have only cos t squared. So you have this. So let's say I change instead this one to sine t squared. Sine t squared gives me this. It is not very well done because the GNU plot is not very well programmed for doing curves which are very smooth. So let's try. I do it with points. So I'm going to set the style function. So set style function instead in this case with points. So unrecognized because I didn't well spelled. I place here style function points. So in order to set, I'll come here function style, I'll say point. Voila, this is what I have. When I have this, I come back again. I'm going to have these points which are going to be shown. Let's say I'll say the line points, in this case lines point. When I have this, I'll come again and I have this which is going to be done. This one is slightly visible, much more visible than the other one we had. So lastly, we can have again another function. So let's say we change the range in which it's going to be involved from -90 to 90. So we change the range from -90 to 90, the domain from -90 to 90 of t squared. Now we do that. So when we change the range, it has slightly changed to this one here. So from here, we say we've seen the basics which are involved in plotting curves, with mathematical curves with GNU plot. We've seen in this tutorial that how we can plot parametric function. In order for you to do that, you now need to set parametric function. And similarly, we've seen how to plot polar functions. And in order for you to do that, you need to set polar. and all of them are going to plot beautiful diagram as such. So from here you see that you can already plot your basic mathematical equations and have mathematical function, create mathematical function with mathematical graphs that you can have for and test it for your pleasure and for much more knowledge that you can have in future. So from here we say thanks for your kind attention, and don't forget to like and subscribe for Science Video Maker channel. Thank you.